Now linear equations of second order with variable coefficients. So far we have solved the linear equations of second order, second and higher order with constants. Now instead of constant we are taking variable constant. In place of constant we are taking 2x, 3x, 3x square, 2y, that type of terms. Means instead of constant we are using variable constants. Then this type of differential equation is also called, means you solve this differential equation by the method of variation of parameters. We have one standard form for this one. The standard form of the linear equations of second order with variable coefficients, d square y by dx square plus p of x into dy by dx plus q of x into y equal to r of x. Previously in place of p of x I got 2, 3, 4, minus 4, that is nothing but constant, purely constant. But instead of 2, 3, 4 I am taking here p of x, means it is purely in terms of x. Means this is nothing but p of x is called variable coefficient. This is called variable coefficient. Q of x is also variable coefficient. Means coefficients of dy by dx previously constant, purely constant, like 2, 3, 4. Now the coefficient of dy by dx is p of x. This is p of x is called variable coefficient. This is the difference between linear equations of second order and second and higher order with general constants. Solve the differential equation by the method of variation of parameters. And definitely in every question they will mention method of variation of parameters. Means if they are not mentioning, means you should not solve the problem by method of variation of parameters. One thing, this is the first observation point. And observe the coefficients of dy by dx. If it is coefficient of dy by dx is variable coefficients, then you should solve by this method only. There is no other method to solve this type of differential equation. These are the important 2 points. Definitely they will mention the method, first point, and the second one, coefficients of dy by dx and coefficient of y must be variable coefficients. Now first problem, solve the differential equation d square y by dx square plus y equal to cosec x. This problem is very little bit different. The previously I observed the RHS q of x. The q of x means first one is q of x is e power x, second one sin bx or cos bx, third one x power k or polynomial in x, fourth one e power ax into v of x, fifth one x into v of x or x power k into v of x. The last one containing 3 functions, means x into v of x. 3 functions, exponential, algebraic function, trigonometrical function. These are the 6 forms. Means in these 6 forms we are not getting cosec x, secant x, tan x and cot x. Means if q of x is secant x, cosec x, tan x or cot x, otherwise log x, then definitely the problem belongs to method of variation of parameters. Now this is also one more to hint to identify the method of variation of problem. RHS side 4 functions, trigonometrical, secant, cosec, tan, cot and log. Now observe this one, d square y by dx square plus y equal to cosec x. The RHS side is q of x is there. Then this problem belongs to linear equations of second order with variable coefficients. Now it is in the form of f of d. I am writing here directly, f of d equal to d square plus 1 and r of x is nothing but cosec x. It is in the form of d square y by dx square plus p of x into dy by dx plus q of x into y equal to r of x. Here p of x is 0 and q of x value is 1. Right. Later we will discuss. First of all, you calculate for this f of d complementary function. For that purpose, you should consider auxiliary equation f of m equal to 0. This implies m square plus 1 equal to 0, m equal to plus or minus I, yc equal to c1 cos x plus c2 sin x equal to c1 u of x plus c2 p of x. This is the general formula of the complementary function for the method of variation of parameters. Means on comparing we get the values of u and v. This is the complementary function by the method of variation of parameters. Here u of x equal to cos x and v of x equal to sin x on comparing with this one. The general formula CF is in this method C1 u of x plus C2 v of x. But again, by using previous method, I got the complementary function C1 cos x plus C2 sin x. Means I am combining, means I am comparing with the general form. That's why I am getting u of x equal to cos x and v of x equal to sin x. And particular integral according to this method, yp equal to au plus bv. A equal to integral minus vr u v dash minus v u dash into dx. B equal to ur dx divided by u v dash minus v u dash. Then the denominator in capital A and capital B, the denominator part is same. That's why I am calculating separately u v dash minus v u dash equal to cos x into cos x. Differentiation of v is v dash, that is cos x, minus sin x into differentiation of u is u dash minus sin x. Finally, cos square x plus sin square x, that is the identity, that is 1. Therefore, u v dash minus v u dash equal to 1. Then a value I am calculating separately, minus v is nothing but sin x by cosec x. Cosec x r of x is nothing but cosec x 1 by sin x into dx. Sin x cancel, integral 1 into dx is x. Another one. Therefore, I got a equal to x, b value integral cos x by sin x dx. Therefore, this is nothing but log of sin x. B, capital B is nothing but log of sin x. The finally particular integral yp equal to minus x cos x plus sin x into log of sin x. Therefore, y equal to yc plus yp. Y equal to c1 cos x plus c2 sin x minus x cos x plus sin x log of sin x. This is the general solution of the given differential equation by using method of variation of parameters.